Hello, today we're going to be talking about atoms and the stuff that makes them, called subparticles. Subparticles. Now, subparticles are the building blocks of atoms. Atoms, by the way, for those of you who are unaware, are the composers of all the mass in the universe. Every object in the universe is made up of atoms, and those atoms themselves are made up of even tinier stuff called subparticles. Now, each atom is composed of a central mass called the nucleus, and the nucleus itself has two parts: a positive part called the proton and a neutrally charged subparticle called the neutron. On those two parts compose the nucleus, and this nucleus is orbited by a cloud of one or more electrons. Electrons are negatively charged. Now, although this picture makes it seem like the nucleus is pretty big, if an atom was the size of say a football stadium, then the nucleus would be about the size of a marble. For atom, the number of electrons is equal to the number of protons, which makes sense because protons are positively charged and electrons are negatively charged, and those two charges have to be equal in order to cancel out and make a charge of zero or neutral. Now, every atom has those three subparticles: the neutron, the proton, and the electron, except for the hydrogen atom, which is lacking a neutron subparticle. It is just a positively charged proton and a negatively charged electron. And the reason the electron orbits proton is due to attraction, also called as a nuclear force, which exists between the positively charged proton and the negatively charged electron. Now, when looking in the periodic table, for example, let's take this symbol, this is, by the way, for the element nitrogen. Now, there's two numbers. The bottom part is called the atomic mass. This represents the mass of the atom, which is made up of protons and neutrons. The reason electrons are not included in this is due to their small size. Now, the top part is called the atomic number. An atomic number represents the number of protons an atom has. Atomic number. So, in a neutral atom, this can also help us find the number of electrons. So, since the atomic number is equal to number of protons, therefore it is reasonable to assume in a neutral atom the number of protons are equal to number of electrons. Therefore, the top number could tell us the properties of two subparticles. So the atomic number could tell us the number of protons and the number of electrons. It could also, with combination of the atomic mass, help us find the number of neutrons. How I mean is, since the atomic number is the number of protons and the atomic mass is protons and neutrons, so the atomic mass is 14 and the atomic number is 7. So this number is purely from the protons. and this is from the proton plus the neutron subparticles. So using that, we already know there's 7 protons, so the rest should be neutrons, and that is how we know there's 7 neutrons in a nitrogen atom. Now, it's very nice in the smaller atoms, the number of neutrons is roughly the same as the number of protons, but as you progress in the periodic table, the number does get a little biased towards neutrons. So let's say gold, for example. Gold, already know there's 7 protons, so the rest should be neutrons, and that is how we know there's 7 neutrons in a nitrogen atom. Now, it's very nice in the smaller atoms, the number of neutrons is roughly the same as the number of protons, but as you progress in the periodic table, the number does get a little biased towards neutrons. So let's say gold, for example. So 79 is the number of protons in gold, or the atomic number. Could also be number of electrons. That's represented in there. And 196.97 would be the number of proton and neutrons. So you could subtract 197 because that's what it is, 196.97, that's 197. You can subtract that by 79 protons to find the number of neutrons that are present in a gold atom, which should give you a value of 100. To find the number of neutrons that are present in a gold atom, which should give you a value of 118 neutrons. And that's how you find the atomic mass. So today we just covered the atomic mass, number, and we went through the definitions for subparticles and subparticles. Now the reason we don't take, I just want to illustrate, the reason we don't take the mass of an electron when finding the mass of an atom, or the reason we don't account for electrons in the atomic mass, is because they're so small compared to the other subparticles. So proton, or neutron are significantly, way bigger than an electron, mass-wise. Charge-wise, electrons are still very important to the atom, and that's their main significance. But trying to account for an electron's mass in an atomic mass is like trying to take an individual's weight when you're trying to measure the mass of a planet. That's the disparity right there in size. So anyways, I hope you guys enjoyed this informative video about atoms and atomic numbers and atomic mass. Next video I'll be discussing periodic table. Alright, have a good one.